Time is fundamental to how we understand and navigate the world. From the steady tick of a clock to the passing of seasons, time seems like an absolute, unchanging aspect of reality. But what if I told you our experience of time is more of a mental construct than a universal property of existence? In this essay, I explore a thought experiment that challenges our Earth-centric concept of time, imagining how human civilization on a hypothetical twin-sun planet might perceive and structure time differently. By examining these alternative temporal frameworks, I uncover the possibility that time, as we experience it, might be less of a universal truth and more of a cognitive tool shaped by our specific environment. Most people don't think about this, but humanity's concept of time is deeply rooted in Earth-specific phenomena, originating from the natural cycle observable from our planet. Our timekeeping system, based on seconds, minutes, hours, days, months, and years, evolved from these cycles, creating a structure that organizes our experience of reality. Ancient sundials divided daylight into 12 segments, based on the shifting position of the sun's shadow. This shadow scale heavily influenced the 12-hour AM-PM system still in use today. The 12-hour division is not inherently tied to any universal feature of time, but rather to a pattern specific to Earth's rotation and solar exposure. The 24-hour day is fundamental to human timekeeping and arises from Earth's rotation. This rotation gives us alternative periods of daylight and darkness, which early civilizations organized into hours. The concept of hours and minutes has become so ingrained that we often treat it as an absolute standard, but it's fundamentally tied to Earth's rotation alone. Earth's orbit around the sun creates seasons, introducing cyclical changes that many ancient cultures used to organize their calendars. Concepts like the year, equinoxes, and solstices are directly tied to Earth's path around the sun. These cycles helped early humans structure agricultural and ritual activities, embedding an annual rhythm in human life and consciousness. Now, imagine human civilization had developed on a planet orbiting two suns. In this twin-sun environment, the day-night cycle might be dramatically different, or even non-existent. This thought experiment allows us to examine how such a society might structure time without the familiar cycles that have shaped life on Earth. Without single sun shadows to create a midday peak, a 12-hour AM-PM system does not emerge. Instead, this society might create divisions based on the position or overlap of the suns, organizing time by light phases or other significant markers in the light cycle. On a planet with two suns, the concept of night could be rare, irregular, or entirely absent. If one sun sets as the other rises, the planet might experience continuous daylight, eliminating any clear division between day and night. If both suns occasionally set at once, there might be brief periods of dim light or darkness, but these would be unpredictable and inconsistent. In such a world, a fixed 24-hour cycle would lose meaning. Time might instead be divided by shifts in light intensity or temperature, creating an adaptable schedule based on environmental conditions, rather than fixed hours. With two suns, the planet might experience long stretches of extreme heat or cold, depending on its distance from each sun, or seasons can be absent altogether. Time might then be structured around changes in solar proximity or solar events rather than an annual cycle. leading to a time system based on astronomical events rather than a fixed year. This thought experiment reveals that time as we know it is highly adaptable and flexible, shaped by the specific conditions of our environment. Comparing Earth's temporal framework with that of a twin sun civilization allows us to consider several broader implications for the nature of time. On Earth, our concept of time evolved from the day-night cycle, seasonal changes, and other natural rhythms. This system feels so intuitive and universal to us that it often seems like an objective reality. However, on a twin sun planet, humans would likely develop an entirely different timekeeping framework based on that environment's unique rhythms. This suggests that time is not a universal, intrinsic property, but a construct shaped by our environment. On Earth, our minds have created a linear structure to explain and organize change. But on a planet with different environmental cues, time might appear cyclical, irregular, or even undefined by fixed intervals. Einstein's theory of relativity established that time is not absolute. It can change based on motion, gravity, and perspective. This thought experiment takes this a slight step further by showing that the very structure of time itself, its divisions, its cycles, its flow, might vary based on local conditions. In this sense, time isn't a single, universal phenomenon that all beings experience uniformly. Instead, it's a framework tailored by each civilization's specific physical surroundings and sensory perception. Time provides humans with a structure to comprehend change, organize experience, and make predictions. This cognitive tool works well in our Earth-centric context, but it may also reveal our limitations. In a twin-sun civilization, time might be perceived as a series of phases, environmental markers, or relational cues. The regular, clock-like sequence that we experience may ultimately be a simplification that our minds impose to organize the continuous change around us. This implies that our cognitive processing is what has led us to experience time as linear because it's practical, not necessarily because it reflects an objective reality. This entire comparison supports the view that time may be a tool for organizing experience, rather than an objective, universal feature of existence. If humans could adapt to a world with different temporal markers, it suggests that time isn't a dimension we move through, but rather a framework we impose to make sense of continuous change. In the context of the universe, this would imply that time is not a universal constant, but a flexible, relative construct that conscious beings adapt to their environments. This flexibility could explain why our experience of time, from a cosmic perspective, appears so limited, perhaps just one possible interpretation of a much deeper and broader reality. Like, share, and subscribe. In Part 2, we'll explore the ways in which humanity measures time and the implications those methods have on the true nature of it.